Listen. Yeah. So last class I told you, when you have a fixed end, there will always be a node, and when you have an open end, there is always an antinode, right? You remember, I hope you guys remember this. Right. So then we saw its application for both the ends tied. So standing wave in a string which is fixed at both the ends. In today's class, we will see what is going to be the length just a minute, guys. There is a lot of issues. Listen. So in today's class, we will see what will happen if both ends are open. So that kind of an object is called as an organ pipe. So organ pipe with both ends open. So if you take a tube, right? If you take a tube which is open at both the ends, and if the tube is of length L, so we are going to find what is the frequency of the sound that is going to get generated in this. So what is the thumb rule? I told you already. So where all do we have antinodes? So antinodes are formed at which point? They are formed at open ends, and nodes are formed at closed ends. Right. So when you look at the diagram, you will have antinode at both the ends and a node exactly at the center. So what is the distance between a node and an antinode? It is lambda by 4. The distance between a node and an antinode is again a lambda by 4. So what should be the value of L here? So what should be the value of L, guys? L lambda by 4 plus lambda by 4, that is lambda by 2. Right, then lambda is equal to 12. But what is the value of lambda? Lambda, how can you write? Lambda in terms of frequency and speed. How do you write lambda in terms of frequency? Distance is equal to speed into time, or speed divided by frequency. So frequency is equal to V divided by F. Sorry, V divided by lambda. Right? So F is equal to V divided by, what is the value of lambda that we got here? Lambda is nothing but 12. So 1 divided by 12 into, it is square root of, remember this, okay? I will explain why it is so later. The speed of the sound in air medium is given as B divided by rho, where B stands for bulk modulus and rho stands for density of the medium. Okay, please make a note of this point. Okay, or sometimes it is written as 1 by 2L into root of, instead of B they write it as gamma times P divided by rho, where gamma stands for, you guys know this, gamma is equal to Cp by Cv. So gamma is called as the specific heat ratio, and P stands for pressure Rho stands for density. Okay. So what is the name of this frequency, guys? You guys tell me. Last class I explained. It's called as F1. So what is this called as? Fundamental
frequency of vibration.
So it is fundamental frequency, or it is also called as first harmonic. Right? So fundamental frequency or first harmonic. So what is the name of this vibration? This is called as first mode of vibration. Okay, please make a note of this point. Okay. Similarly, the second one is, what do you mean by second mode of vibration? So I told you the mode of vibration is decided by whom? The number of standing waves that are formed. So when I talk about second mode of vibration, there will be two standing waves inside. Right. So what is the distance between a node and an antinode? It is lambda by 4. What is the distance between two successive nodes? That is lambda by 2. What is the distance between a node and an antinode? Again lambda by 4. So it is the same length L. Right. It is the same length L. Then what will be the frequency? Frequency is nothing but speed divided by wavelength. Right. So 1 divided by, what is going to be the wavelength here? Lambda by 4 plus lambda by 2 plus lambda by 4 is equal to L. So how much is the value, guys? Lambda by 2 plus lambda by 2, that is lambda is equal to L. So here 1 by L into root of gamma p divided by rho. Is there any doubt in this? So what is the name of this vibration? F2, what is the name of this frequency? This is called as first overtone, or what harmonic?
Second harmonic.
It's called second harmonic. Okay. So this I can still write it as 2 divided by 2L into root of gamma p divided by rho. So F2O is called as first overtone or second harmonic. Similarly, third mode of vibration. So how many standing waves will you have? Within the same length L, there will be 3 standing waves, right? Lambda by 4, lambda by 2, lambda by 2, lambda by 4. So what is going to be the total length? That is lambda by 4 plus lambda by 4 plus lambda by 2 plus lambda by 2. How much is this? Lambda by 2 plus lambda by 2 is lambda. Lambda by 4 plus lambda by 4 is lambda by 2. Lambda plus lambda by 2 is 3 lambda by 2, which implies lambda is equal to 2L divided by 3. Okay. So frequency is equal to V divided by F. Sorry, V divided by lambda again. 1 by 2L divided by 3 into V. That is 3 by 2L into square root of gamma P divided by rho. So what is the name of this frequency? This is F3. This is called as second overtone or third harmonic. Okay. Similarly, if I keep on doing, if it is for the nth mode of vibration, what will be the value of frequency? Fn will be equal to, you guys tell me.
N by 2L.
12 into square root of gamma p divided by rho. Right, this is called as what? This is called as n minus 1th overtone, or it's called as nth harmonic. Okay, make a note of this point.
Sir, I have a doubt.
Tell me.
What's in the denominator below gamma p, sir?
I didn't get it. What's in the denominator?
Below gamma p.
It is rho. That is density of the gas in the medium.
Okay, sir.
Okay. So I hope it is done. So this is all about stationary waves. This is called as stationary waves in organ pipes. Okay. Next is
Sir, pardon me, the screen is stuck, sir.
okay.
Yes, sir.
Next is so the next topic of discussion is closed organ pipe. So let me explain what this closed organ pipe is. See, closed organ pipe means not like both the ends are closed. One end is open and the other end is closed. So one important point to be noted is when I talk about an organ pipe or air column, see, organ pipe is also sometimes called as air column. Okay. When I talk about only an organ pipe, if it is mentioned only as organ pipe, by default it is open at both the ends. Whereas when they use the word closed organ pipe, one of the ends is closed and the other is open. So organ pipe and the string which is fixed at both the ends have the same concept. If you observe, everything will be the same, except the fact that in the case of a string, speed is root of t by mu, whereas in the case of air column, in the case of air medium, the speed of sound is given as root of gamma p by rho. Okay. Here also the speed is root of gamma p by rho only. But the things will be slightly different here. Observe carefully. So when I talk about a closed organ pipe, its length is still going to be L only. Okay. But what do you think is going to be the difference? When I spoke about a string, which is fixed at both the ends had nodes. Right? Whereas when I spoke about an organ pipe, both the ends have antinodes. When I talk about a closed organ pipe, what do you think will be the difference? Since one of the ends is closed, one point will have a node and the other point will have an antinode. So when you take it like this, it will be something like this. Right? So what is the distance between a node and its successive antinode? So what is this distance, guys?
Lambda by 4.
Yes. So in the first mode of vibration, right, when I talk about the first mode of vibration, how many nodes will be there? There is one node and one antinode. So what will be the length? L will be equal to lambda by 4, which implies lambda is equal to 4L. Accepted? So frequency will be equal to V divided by lambda. So 1 by lambda is nothing but 4L into root of gamma P divided by rho. Okay. So what will be the name of this frequency? It's called as F1. This is called as the fundamental frequency, or which harmonic? It's called as the first harmonic. I hope this point is clear. Right. Is it clear?
Yes, sir.
Now I have a question. If I talk about second mode of vibration, okay, if I talk about the second mode of vibration, then how many how many standing waves do you think I'll have? See, in the other two cases, when I told second mode of vibration, the number of standing waves will define the mode of vibration. So when I told second mode there were two standing waves. Whereas what will happen here?
Will be one, sir.
It will not be one, because you can never get one complete standing wave. When I talk about one end to be node and the other end to be anti-node, this is only half of a standing wave. Then how many standing waves do you think we'll have in the second mode of vibration? You will have one complete standing wave and an other half standing wave. So this distance will be lambda by 2 and this distance will be lambda by 4. Okay, so what will be the value of L? Lambda by 2 plus lambda by 4 will be equal to 3 lambda by 4. Got it, guys? So you understood. So what will happen? So lambda will be equal to 4 times L divided by 3. So what will be the frequency? Frequency will be V divided by lambda. So V is root of gamma P divided by rho. Lambda is 1 by 4L divided by 3. That will be 3 divided by 4L into root of gamma P divided by rho. So what is the difference? 1 by 2L, so 1 by 4L, and the next number you have in the numerator is 3 by 4L. So what will be the name of this frequency? This frequency is called as first overtone, or it is actually called as third harmonic. So this is the point you need to be careful. In all other cases, it will be the mode of vibration will define the number of harmonic. Whereas in this case, what will happen is, since you don't have two complete standing waves, it is called as third harmonic because the numerator is 3. And it is called as the first overtone because this is how a standing wave is formed after the fundamental frequency. Guys, please make a note of this. Am I clear with this? So this is nothing but 3 times the fundamental frequency. This is what I call it as F2. Actually, we can call it as F3. Okay, the reason why I'm calling it as F3 is because I'm taking this number into consideration, the numerator of this into consideration. Am I clear with this point, guys? Now listen. Now answer this, you'll get third mode of vibration. So when I talk about the third mode of vibration, how many standing waves do you think I'll have?
Complete.
Yes.
2.5, sir.
So you will have 2.5 standing waves. You will have 2 complete and 1 half standing wave. Okay. Distance between two nodes is lambda by 2, and this is lambda by 4. See, the diagram is not to the exact scale. So what will be the value of L? Lambda by 2 plus lambda by 2 plus lambda by 4. How much is that? Lambda plus lambda by 4 is 5 times lambda by 4.
Lambda by 4.
So lambda in this case will be 4 times L divided by 5. So what will be the frequency? 1 divided by 4L by 5 into root of gamma P divided by rho. That will be 5 by 4L into root of gamma P by rho. Can I call this as F5? Now you tell me what will be the name of this by taking this into consideration. So it's called as which overtone and which harmonic?
Second overtone, fourth harmonic.
Fifth harmonic.
It's called an important point to be noted in the case of a closed organ pipe is, right, you can never have even harmonics, rather you will have only odd harmonics. So this is a very, very important point in this case. So this would be 5 times the fundamental frequency, right? Like this, if I keep on writing, so can you tell me what is going to be the frequency of the nth mode of vibration? Frequency of nth mode of vibration is how much? If I write it as f, then what will be the frequency of nth mode? What am I getting in the numerator? So if you observe something by 4L into root of gamma p divided by rho, is it not common everywhere?
Yes, sir.
Right?
It's common.
It is common everywhere. Then what should I have in the numerator?
Odd number.
Odd number. So how do I write that odd number?
N plus 2.
N plus 2 is not odd number. How is n plus 2 odd number?
N
No.
plus 1, sir.
N plus 1 is also not odd number. See, n plus 1, if I put n is equal to 1, 1 plus 1 is not an odd number. See, odd number is always formed from an even number. Even number is
2n
2n.
minus 1.
It can either be 2n minus 1 or plus 1. Tell me in this case, what one should I choose? That is decided by the
2n minus 1.
that is decided by the mode of vibration. Yes, tell me.
Two n minus 1, sir.
So you want me to take it as 2n minus 1? Yes, 2n minus 1 divided by 4L into root of gamma p by rho is going to give us the frequency. Okay, so what will be the name of this frequency? It's called as which harmonic?
2N minus.
It is called 2n minus 1th harmonic, or what will be the overtone for it? So when it was third, we called it as first overtone, right? When it was sorry, it will be n minus tell no
3.
n minus
minus 1.
3. It is n minus 1th harmonic, no? Nth minus n minus 1th overtone. Because when I take n as the second mode of vibration, we got the first overtone. When I took it as third mode of vibration, I got the second overtone. When I take it as the third mode of vibration, I'll get the third overtone. You're able to understand? So it keeps on going like this.
Sir,
Anyways,
sir, when you take N as 5, you got second overtone, no, sir. How, sir? 4th?
where did I take? I didn't take n as 5. Here I wrote it as 2n minus 1. This 5 and this 5 are matching. That is how I took. Okay, here it is 5, the numerator is also 5. Here it is 3, numerator is also 3. So this is not fn, this is f of 2n minus 1. So f of 2n minus 1 is equal to 2n minus 1 by 4L into gamma p by rho, where that frequency is called as the 2n minus 1th harmonic or n minus 1th overtone. Now you calculate and see, you will get it. Where that n stands for what mode? N stands for the mode of vibration. And n is mathematically an integer. Okay. So make a note of all these points. Okay. So this is all about standing waves. Now I have to explain how this formula has actually come. That I will show now. Listen. Okay. So I'm not explaining all these points because they are not from the CBSE perspective. Listen to this carefully. So whenever you want to calculate the speed of a sound wave or speed of a wave, so write down this point. So when I talk about the speed of a wave, I can either calculate speed of a transverse wave or a longitudinal wave. So when I talk about the transverse wave, I'm talking about the wave on a string. That is an example. When I talk about a longitudinal wave, it is the sound that is an example. Okay. So write down this point. This is a very, very important point. Based on this only, all these things are derived. So whenever you talk about any speed of a wave, right, it depends on two important properties. So write it down. Wave velocity through a medium. So in the first case, in the case of a transverse medium, transverse wave, string is the medium. In the case of longitudinal wave, air medium, water medium, it can be anything. So wave velocity through a medium depends on two properties. One is its inertial property, and the second is its elastic property. Okay, these are the two important points. Wave velocity through any medium depends on the inertial property and the elastic property. Okay. So with the same context, if I'm trying to calculate wave velocity on a string, if I try to calculate the wave velocity on a string, then it should depend on the inertial and the elastic properties of a string. So what defines the inertial property of a string? Remember, inertia is directly proportional to mass. So inertial property of a string is defined by its linear mass density. That is what is mu. So how you define mu is, it is defined as the amount of mass per unit length. Guys, am I clear with this? Okay. Similarly, what is the property that defines the elasticity of a string? Elastic property of a string is nothing but its tension. Okay. And the reason being, without tension, no disturbance can propagate. Without tension, no disturbance can propagate in the string. Propagate means travel. Am I clear with these 2 points? So I'm stressing on the important points. Whenever you want to calculate the speed of a wave, then speed of a wave in a medium is dependent on two important properties. What are they? One is the inertial and the elastic property. It is applicable for transverse and longitudinal. So the first that we are going to study is, we are going to calculate the wave velocity on a string. When we derive the fundamental frequency, I gave you a formula. What is that? V is equal to root of T by mu. I hope you remember this. Now I am actually going to show you the derivation of this. Okay. Now, I'm going to use dimensional analysis. Now see, speed is directly proportional to, can I write it as t power a into mu power b? That is how we do dimensional analysis. Right? So, v is equal to some constant times t power a into mu power b. Accepted? Where k is a dimensionless constant. Now see. Can I say the dimensional formula of v is equal to dimensional formula of t raised to the power a into dimensional formula of mu raised to the power b? So what is the dimensional formula of v? m0 L1 t minus 1. Because velocity is meter per second is equal to, tell me what will you use for the dimensional formula of tension. Tension is force. Force is mass into acceleration. So you will have m L t minus 2 raised to the power a. Accepted, guys? Into. What is mu? Mu is mass per unit length. So mass is written as m and length is written as L. So L minus 1 to the power b. Any doubt in this?
No, sir.
Okay. Now our work is to compare, collect all the terms and then compare. So a plus b, L of a minus b, t power minus 2a, m0 L1 t minus 1. So a plus b is 0, a minus b is 1, minus 2a is minus 1. So a plus b is 0 means a is equal to minus b. Minus 2a is equal to 1. You understood how I got minus 2a? Sorry, 2a is equal to 1 because in the place of minus b, I replaced it with a. Then I got 2a is equal to 1, which implies a is equal to half. So when a is half, b will be minus half. Okay. So v is equal to some constant times t power constant times sorry, t power a. A is half, mu power minus half. So can I write it as k into root of t by mu? Guys, any doubt till here? Just go through it. Let me know if there is any doubt.
Sir, can you explain that how you wrote a plus b, a minus b that now?
Mithun, there is a lot of disturbance from your side. I'm not sure. I've told this many times. When you switch on, no, there is some bus sound that is coming. What did you ask? I didn't hear.
Sir, can you explain how did you get that a plus b, a minus b, the things and all?
I collected all the powers. This is how we do the first chapter. M power a, L power a, t power minus 2a into m power b, L power minus b. So multiply m power a into m power b. That will be m power a plus b. L power a into L power minus b. L power a minus b. T power minus 2a, t power minus 2a. That's how I got.
Okay, sir.
Okay. So this is how we get. So this is the speed of a wave velocity on a string. Now, experimentally, it was found out that k is equal to 1, which implies v is equal to root of t divided by mu. Now, you guys understood why I wrote t by mu there, root of t by mu.
Sir, why, sir?
This is the reason I've derived it, no? This is based on dimension. When I substitute k is equal to 1 here, v is equal to root of t by mu.
Okay, sir. Understood now, sir.
So here I wrote, no, this is what I wanted to show. 1 minute. Where is it? Here I wrote, no, root of t by mu, because this was also a concept related to string. Okay. Next. Can I move on to the next one? Next one is speed of longitudinal wave. Okay. So again, what will be the elastic property? We'll do one thing. So speed of a longitudinal wave in a liquid or gas. So what is the speed of a longitudinal wave in a liquid or a gas? What will be the elastic property of it? And what is going to be the inertial property? So remember, when I say longitudinal wave, mostly you will talk about sound. Okay. So when I talk about the sound, how does a longitudinal wave actually travel? It travels in the form of compressions and rarefactions, right? So what is the elastic property that is going to define, or that is elastic property defined for a longitudinal wave in a medium? The answer is very simple. When I talk about a liquid or a column, they need volume to be occupied. So the elastic property that defines the medium is bulk modulus. Okay, it is bulk modulus. Similarly, what is going to be the inertial property of that medium? Inertial property has something to do with mass. But for a liquid, we cannot define mass. Rather, we can define mass per unit volume. That is nothing but density of the fluid. Okay. Now again, bulk modulus, if I write it as B, and density if I write it as rho. This density is mass per unit volume. Then speed, again dimensional analysis. Speed is directly proportional to B power A into rho power B, which implies speed is equal to K times B power A into rho power B. Accepted? So speed is equal to, or dimensional formula of speed is equal to K into dimensional formula of B power A into dimensional formula of rho power B. So again, dimensional formula of V is M0 L T minus 1 is equal to, what is the dimensional formula of bulk modulus? It is M L minus 1 T minus 2, because bulk modulus is the same as pressure. Pressure is Newton per meter square. Newton per meter square is ML minus 1 T minus 2 raised to the power A. What will be the dimensional formula of density? M L minus 3 to the power B. Okay. So this will be M power A plus B, L power minus A minus 3B, T power minus 2A. This is M power 0, L power 1, T power minus 1. So A plus B is 0, minus A minus 3B is 1, minus 2A is minus 1. From here I can get A is equal to how much? Half. If I take A is equal to half and substitute it here, minus half minus 3B is equal to 1, which implies minus 3B is equal to 3 by 2, which implies B is equal to minus half. Right? So B will be how much? K times B power half into rho power minus half. That is K into root of B divided by rho. Experimentally, what will you say? K is equal to 1. If I substitute it here, B will be equal to root of B divided by rho.
So I have a doubt, sir.
Tell me.
What's the use of K here, sir? Why are we using K?
That is because in dimensional analysis, you have to always introduce a constant in the derivation.
Necessary, sir, always.
Yeah, it is always necessary. That is, so see, if you revisit the units, that is the first chapter, sorry, second chapter, time period of a simple pendulum also you can derive it using dimensional analysis. There you will have K into root of L by G. But now you know what is that value of K, no? According to simple harmonic motion. That is 2 pi. If you don't write that K, then your answer will go wrong. In viscosity also, we would have used this for Stokes law and everything, no? Dimensional analysis. There the value of K will be 6 pi. So everywhere, wherever you're using dimensional analysis method, a constant, a dimensionless constant has to be introduced. It is mandatory. But the drawback with this method is you cannot find it from the theory part. You can only find it experimentally. Since somebody told us experimentally this value is 1, we are using it. That's it.
Understood, sir.
Okay. Now I will show you one more formula. So remember this, okay? So whenever I ask you what is the speed of a sound wave in liquid or gas medium, it is going to be square root of B divided by how much? Square root of bulk modulus divided by the density. So please make a note of it. Now comes an important point. Now we will try to calculate what is the speed of a sound in air medium using a formula called as Newton's formula. Okay, so concentrate, guys. So that will be the last topic for today, and there will be 2 more subtopics that we'll do it on Wednesday. Tomorrow there will be no class. We'll do it on Wednesday and finish it off. Newton's formula for speed of sound. Okay. Remember, the speed of sound's general formula is root of B by rho. But why I'm calling it as Newton's formula is because Newton assumed that sound traveled in a fluid medium, mostly in air medium actually, under isothermal conditions. So that is what he took into consideration. So he proposed saying that sound traveled in air, or I can call it as a gas medium. Let's not generalize it to air. In a gas medium under isothermal condition. Okay. So here one important point I want you to recollect is what is the basic formula for bulk modulus in terms of pressure and change in volume? It is pressure divided by minus dV by V. Do you guys remember this? Or delta V by V also. Pressure stands for stress. Stress by strain is the modulus of elasticity. Bulk modulus is one of the modulus of elasticity. So pressure divided by dV by V is what is the bulk modulus. So I hope you remember this. Now tell me, for isothermal condition, what is the mathematical equation that we are going to write in terms of pressure and volume? Pressure into volume is always constant. So pressure into volume is constant means differentiate on both sides. Okay. So when I say differentiate on both sides, generally I will tell with what parameter you are going to differentiate. Okay. Now what we can do is I'll say differentiate on both sides with respect to volume. Let's see what is going to happen. So you people know what is UV method, right? D by dV of pressure into volume is equal to D by dV of a constant. So what is the derivative of a constant? It is a 0. Right? So what will happen on the left hand side? So pressure into dV by dV plus volume into dP by dV. Can I write it like this? Is equal to how much? Zero. Okay, one small correction. I'm doing it as dP because I'm applying a differential pressure here. So dP divided by minus dV by V is nothing but bulk modulus. Now see how I'm going to rearrange the equation. So if dV is gone, can I write it as P dV by dV is equal to minus of V dP by dV? So if the denominator part is eliminated, you can write it as P dV is equal to minus V dP. Is there any doubt till this step? Let me know.
No doubt, sir.
Now comes an important point. If I write it as P is equal to minus VdP divided by dV, this V comes to the denominator, it will become minus dP divided by dV by V. What is this whole thing, guys?
Bulk's modulus, sir.
That is what is bulk modulus, right? But according to this derivation, bulk modulus is equal to what value? P stands for pressure. So according to Newton, the bulk modulus is exactly equal to the pressure. Then what will be the speed of the sound in that medium? Speed is known as root of B by rho. Root of B can be replaced with what? Pressure divided by rho. So according to Newton again, according to Newton's formula, V is equal to root of P divided by rho. Okay, it is root of P divided by rho. I hope you understood. But there is a mistake in this. This was later corrected by a scientist known Laplace. So he made some corrections in it. The only correction I'll tell you, I will outline. So what did Newton assume? He assumed that the sound travels in a gas medium under isothermal condition. But Laplace made a correction saying that it doesn't travel under isothermal condition, rather it travels under adiabatic conditions that I will show in the next class. So till then, you can make a note of this. If there is any doubt, you can get it clarified now.